Just continuing from where we left off, the last question we were solving exponentials, and so now when we have exponentials, we're talking about using law of logs, using the inverse idea. Get familiar with both of them, which one you feel is the most confident, or which one you feel is the easiest for you, and then I would go with it. Now, when we look at solving logarithms, if it's already in logarithmic form, then it's a little bit different because now we're in that inverse state. So to look at this right now, we have 2 log base 7 of x is equal to log base 7 of 27 plus log base 7 of 3. So the first thing I want to do is kind of get these down to be a single log. We want log of some number. Oops, sorry here. Yeah, let's just leave it that way, I guess. Let's just write it red. So we want log base some number of, let's say, y is equal to log base x of, let's say, z. So therefore we can say y is equal to z. So our goal is to get them to be able to just drop them down and solve it. But you can't do that until you have a single log and a single log. So with that said, right now our goal is to get to a single log or find some way of showing that. So by doing so, we first of all take this 2 and it becomes our exponent. So write this as log base 7 of 2, and then addition when between logs, like based on our recall slide, means that we are multiplying. So we're going to multiply 27 times 3. So we got this down to a single log. We get log base 7 of x squared is equal to log base 7 of 27 times 3, which is equivalent to 81. Now, because we have common logs, and because you have logs that are on both sides that are exactly the same, in order for these to be equal, they have to have same basis. So therefore, we can kind of, in a way, cross these out, cross this out, and then whatever's left gets dropped down. Whatever's left gets dropped down. So we get x squared is equal to 81. And then we turn into our algebra, our skills of figuring out how do we solve for x. So we're going to take the square root of both sides. And keep in mind that we're adding the plus or minus feature because we want 2 values with the degree. So what is the plus or minus the square root of 81 is equal to positive or negative 9. And the only thing we want to worry about and we want to make sure is that we get x is equal to 9 or x is equal to negative 9 is when you plug these numbers right here back into the original, plug these numbers right here back into the original of the x, as long as we don't get a negative there. But we also want to make sure that since we're squaring it, I would actually plug it back into the other coefficient here, because 9 squared is going to be 81, negative 9 squared is going to be 81, so thus my answers for this one are going to be x equals 9 and x equals negative 9. The negative 9 will work because of the fact that we're squaring it. Alright, so now if this was cubed and it was negative 9 cubed, then you're going to get negative, what is it? You're going to get a negative value out. And since you take log base 7 of a negative solution, then the x value would not work because of the fact that we cannot take log base of anything that is negative. So again, solving logarithms, our goal is to get down to 1 log is equal to 1 log. So with this process, we want log equals log. If we can't get that, then we'll talk about how we can't. But our first thought should be, if they're the common bases and we can find common bases, let's solve them that way. And next, kind of like this next one. Next one's the kind of same similar process. We need to condense this side down. We got nothing to worry about here. There's no coefficient out front. So we got to get just to carry this log base 8 of x plus or 65 down. The negative means that we are going to divide. We're going to divide these two expressions. So x minus 1 divided by 2. So we get log base 8, leaving the common logs. And again, because we have the common bases, we can kind of cross those out, leaving our expression of x minus 1. Drop it straight down. drop straight down, leaving the expression of x minus 1 over 2 is equal to 65, and then we solve from there. So we're going to multiply both sides by 2. We get x minus 1 is equal to 130, and then you add 1 and you get x equals 131. Again, plugging this back in, making sure that we are going to have a positive value. 131 minus 1 is 130. 130 divided by 2 is 65. Thus, we have proven these both sides are equal. So we always want to plug it in. We're making sure that this expression, x minus 1, is not equal to 0. Has to be, let's just say this, x minus 1 has to be greater than 0 in order for this to be a solution and just be able to value. So that's why we're checking our answers. So the answers for this one, on this expression, is x equals 131. Now, if you notice so far, we've got common log, common log, common log. They're all the same. We condensed it down to 1. Well, what happens if we have, let's say, log 8 of x minus 1 is equal to 2? So you condensed it, you reduced it down, and we don't have this value here. Then we're going to get into a little bit different process. We're going to kind of be forced to switch to exponentials. So thus, an example like this. So first thing, we want to get down to condensing as much as possible. We get this as small as possible. So addition means that we are going to multiply. I'm going to multiply the x and the x minus 5. So it becomes log base 6 of x times x plus 5 is equal to 2. Notice it didn't do anything with the 2. And since we don't have logs on both sides, I have to figure out how can I solve this? How can I get out of logarithm form and get into a form that I do know how to process and I do know how to work with? So I can't just go x minus x times x plus 5 is equal to 2 because I don't have a log 2 here. If this was log base 6 of 2, this whole thing was in place of that, then yes, drop it down, solve it the way we just got done doing in the first two examples. Here, though, since it's in logarithmic, we're going to switch this to exponential. I'm going to go 6 to the second power, so base to what exponent is equal to what solution? So that becomes 6 squared is equal to x squared plus 5x. And now our factoring techniques kick in. We see a quadratic. We're going to set this equal to 0. So I'm going to minus the 36. And I'm going to say now, what are factors of negative 36 that multiply to negative 36 but add to 5? And that's going to be a positive 9 and a negative 4. So I get factors of x plus 9 and x minus 4. And then my answers are x equals negative 9 and x equals 4. And then when we plug it back in, we're going to plug it back in here. We plug the negative 9 in. We have a negative there. Negative and negative make a positive. Thus, this expression does work. So both those answers would be negative 9 and 4 because we're plugging them into this expression right here. A negative times a negative becomes a positive. Thus, our solution would work. So we get 4. 4 times 9 is 36. So you get log base 6 of 36 is equal to 2. So let's check that. 6 squared is equal to 36. Therefore, we checked our answer. We know those answers are going to work. When I plug in 4, I plug in negative 9. I get log base 6 of 36 is equal to 2. Because I'm telling you, we're telling the exponent, we're trying to figure out what solution makes the left side equal to the right side. And this is when you have a log of some number and some value is equal to some other number. So we only have a single log. So we want to think of this process as a single log. So in this case, as an acronym, they're singles. Where back before, we had a double logs on both sides. So traveling in 2 pairs. So if they have double logs, we can just drop as long as there's one on each side of the equal sign. Where if it's a single log, then we have to switch to exponential. So from here to here, we switch to exponential form to solve. So looking at this next one here, this last one we're talking about, again, we know we have a single log So when I see a single log, I know I need to be thinking exponential form as fast as I can. But I can't do that till I have a single log, so I change this to log base 5 of x minus over 2. Again, subtraction means we divide. I change this to the exponential form. So loop and swoop, log b of a equals x, which is b to the x power is equal to a. So log of 5 squared equals x over 2. 5 squared, loop, and swoop. 5 squared is equal to 25 over x minus 2. Multiply by 2, and you get x is equal to 50. And then we're just getting in the habit of double checking. If I plug 50 back in here, as long as this is not a negative, we have an answer. So my answer here is x equals 50. So just reiterating, single log, we got to go to exponential. If it's a double log, we can just straight up get them down to be condensed on each side, cross them out and solve. So set them equal to each other. And this concludes the lesson on how to solve exponential equations and how to solve logarithmic equations when bases are not the same and we're forced to use different techniques rather than just common bases. So thank you for your time. Apologize for being a little lengthy, but walk through a lot of examples for you. Thank you.